So this video we are going to see the next topic under relations and functions. That's nothing but the types of functions actually. So there are types of functions. Mainly I will be going on to what is meant by a one-to-one function and an on-to function here. So here I'll explain it with an arrow diagram here. Suppose I have two sets here, A and B. So here we have it as 1, 2, 3, 4, and here maybe I'll have it as A, B, C and D here. Okay. So here if you see 1 is mapped to A, 2 is mapped to B, 3 is mapped to C and 4 is mapped to D. So you all know this we call it as the domain. This we call it as the codomain. Okay, and the elements in it, this only we call it as the range. Okay, so here this only we call it as the range in this case actually here. So what is a one-to-one function? A one-to-one function is nothing but all the elements in the domain will have unique images. That is, 1 will have only one image, 2 will have only one image, 3 will have only one image, 4 also will have only one image. That only we call it as a one-to-one function. In other words, suppose if I have it like this, if f of x is equal to f of y, then we say that your x is equal to y. So we say that f is said to be 1 to 1. So here this is the one-to-one function definition whatever we have in our textbook actually here. But arrow diagram wise, if you see here, this is how we explain here. Okay, so here what is meant by an on-to function? So what is meant by an on-to function here? Suppose I have it as 1, 2, 3 and 4. I have it as A, B and C. I say that 1 is mapped to this one here, 2 is mapped to this one, 3 is also mapped to B and 4 is also mapped to C here. Okay. Now when you have a look at this function, if you see, in this case, it's not a one-to-one function because 2 and 3, if you see, they have the same image, but it's an on-to function. Why I say that it is said to be an on-to function is all the elements in the codomain. I told you this is nothing but your codomain. I told you actually here. All the elements in the codomain, they have a pre-image. See here, what is a pre-image? The pre-image of A is nothing but 1. The pre-image of B is nothing but 2. The pre-image of B is nothing but 3. The pre-image of C is nothing but equal to 4. Suppose I had it like this. I had D here. Okay, suppose this D doesn't have a pre-image. Then I will say that it is not an on-to function. You understood? It's not an on-to function in this case. This also can be called as a many-to-one on-to function because here if you see, these two elements, if you see here, the images here, if you see in this case, it has got the same image here, 2 and 3. That's a reason also we can call it as a many-to-one function. So this is a on-to function. So this is what you're going to see under this exercise 1.2. Okay, so here another name given to this one-to-one function is nothing but injective function. Injective function, or we call it as a one-to-one function. Okay, so injective, or we call it as one-to-one. Similarly, this one we call it as surjective. This one we call it as a surjective function, or we call it as an on-to function. So if your f is said to be injective, okay, so here if f is said to be injective and surjective, that is if it is said to be one-to-one and one-to, then it is called as a bijective function. Okay, so here we call it as a bijective function. These are the terms we need to know under this case. It's said to be one-to-one and on-to, then we call this as a bijective function. Okay. So under this exercise 1.2, show that the function f from r star to r star defined by f of x is equal to 1 by x is 1 to 1, where r star is the set of all non-zero real numbers. The result, what will I get here actually here? It is said to be the set of all non-zero real numbers we have here. Okay, it is said to be the set of all non-zero real numbers. The result true if the domain r star is replaced by n with the codomain. Okay, so here this is what is given here. So here in this case, you're given here your f of x is equal to 1 by x. This is what is given here. So I've drawn the arrow diagram in this case. So it is a set of all non-zero real numbers, your r star. So what is that you get here? Suppose these are all the set of all real numbers I get here, non-zero, minus 1, minus 2, minus 3, 1, 2 and 3. So when I replace it, minus 3 is what? To minus 1 by 3. Minus 2 if you see to minus 1 by 2, minus 1 to 1, 1 to 1, 2 to 1 by 2 and 3 to 1 by 3. How I write it as 2 to 1 by 2? F of 2 is what? It is equal to 1 by 2. What is your f of 3? It is equal to 1 by 3. Therefore, you get f of x to be equal to 1 by x. This is what you have here. Okay. Now here if you see, I'll just look at the arrow diagram and I will mention it, I will explain it, and then I'll go over to this explanation part here. So here if you see, all the elements in the domain, they have unique images. Is it clear? The images are not repeated. So they have unique images, and therefore I can say that f is said to be 1 to 1. Got it? Now when you have a look at the codomain here, okay, so here when you have a look at the codomain also, here if you see, all the elements in the codomain also have pre-images here. Do they have pre-images? Yes, they have pre-images. Therefore I can say that it is said to be onto. So see how I have proved it here. If f of x1 is equal to f of x2, your 1 by x1 is equal to 1 by x2. So you get your x2 to be equal to x1. And thus you say that f is said to be 1 to 1. Got it? Now here the next one, if f of x is equal to 1 by x, you take y to be equal to 1 by x, which implies your x is equal to 1 by y. This is what you get here. So what will I get here? Your f of 1 by y is equal to 1 by 1 by y. That's nothing but equal to y. Therefore you say that your f is said to be onto, and thus your f is said to be 1 to 1 as well as onto. Got it? Now here the second question, check the injectivity and surjectivity of the following functions it is given here. So f from n to n given by f of x is equal to x squared. So here in this case, you have it as the domain and the codomain are nothing but a set of all natural numbers, because it is given from f from n to n here. So a set of natural numbers to natural numbers. So what are the natural numbers you get here? 1, 2, 3, etc. It goes on. Here also it is 1, 2, 3, etc. So when I take 1, what is your f of 1 equal to actually here? Your f of 1 is nothing but equal to 1 square. So 1 is mapped on to 1. Similarly, when I take f of 2, what is it? It's 2 squared. What is 2 squared? It's equal to 4. 2 is mapped on to 4. 3 squared, it is to 9. So when you look at it, it is a 1 to 1 function, because every element has got only a unique image here. But when you look at the pre-image, this is the codomain you get here. Do all the elements have pre-image? No. 2 doesn't have a pre-image. 3 doesn't have a pre-image. 5 doesn't have a pre-image in this case actually. In other words, I can say that your range is only a subset of the codomain. Only if your range is equal to the codomain, I can say that it is said to be a onto function. So range is only a subset of the codomain. So see how I have written here. F of x is equal to f of y, x squared is equal to y squared, you get x to be equal to y, therefore your f is said to be a 1 to 1 function. So f is not onto, since all the elements in the codomain do not have a pre-image. In other words, your range is said to be a subset of the codomain, therefore your f is not onto. Is it clear? But it is 1 to 1 but not onto. So as I told you for the previous one, they do not have a pre-image, and therefore f is not 1, 2. Okay. Now we'll take the second subdivision. F from z to z given by f of x is equal to x squared you have here. So f of x is equal to x squared means what will I get here? It's from z to z. So what do you mean by z to z? It's a set of all integers to the set of all integers you get. So 0, 1, 2, 3, 4, 5, etc. Here again it's minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, etc. you get here. The same way here also. So when I take f of minus 1, what is f of minus 1? It is also equal to 1. So here it is equal to 1. So when I take f of 1, what is f of 1? That is also equal to 1. Similarly, I take f of 2. What is that equal to here? That is also equal to 4. F of minus 2. What is it equal to? That is also equal to 4. Okay, so 2 is also equal to 4. Minus 2 is also equal to 4. Now looking at the arrow diagram itself, you can say whether it is 1 to 1 or not actually here. It is not 1 to 1 actually here, because the reason you have it here, if you see 1 and minus 1 have got the same image. What is the image you get here? It is nothing but 1 itself actually here. So it is not 1 to 1. Similarly, is it surjective or is it on to actually here? No. Why do I say it is not onto? Because all the elements in the domain do not have a pre-image. Therefore, you say that f is not onto also. So here in this case, f is not 1 to 1. And all the elements in the codomain does not have a pre-image. Therefore, you say that f is not onto. Got it? So, why do I say it is not 1 to 1? F of 1 is equal to f of minus 1. but 1 is not equal to minus 1. Therefore, you say that it is not 1 to 1 and on to. In other words, it's not injective and surjective. Got it? Now here your third subdivision, f from r to r given by f of x is equal to x squared you have here. So in this case again you have it as r to r is nothing but the set of all real numbers. So you know set of all real numbers, it can have all type of numbers you can have here. So I just written the whole numbers alone here, okay, 0, 1, 2, 3, 4, minus 1, minus 2, etc. here. Now again we have the same issue in this case. It's not 1 to 1 like the previous one. Here if you see 1, it has got the same image, minus 1 also will have the same image. Similarly 3 also will have the same image, 3 and minus 3 will have the same image. Therefore I say that it is not 1 to 1. And all the elements in the codomain also does not have a pre-image, because here in this case only the positive numbers, positive real numbers will have a pre-image. The negative real numbers will not have a pre-image in this case. And therefore what do I say in this case? Your f is not onto, or we say that your f is not surjective. Got it? Yes. Now here the third question. Prove that the greatest integer function f from r to r given by f of x is equal to greatest integer of x is neither 1 to 1 nor on to, where greatest integer of x denotes the greatest integer less than or equal to x. Okay. So here it is given by f from r to r by f of x is equal to greatest integer of x you get here. So already we have seen what is meant by greatest integer of this one is what actually here. Suppose if I have it as 2.2, that is also equal to 2, 2.9 that is also equal to 2 itself. That is you will be taking only the integer value in this case. So f of 2.2 that is also equal to 2, f of 2.8 that is also equal to 2. So what is your f of 2.2 equal to? If f of 2.2 is equal to f of 2.8, because I can say these are equal, but your 2.2 is not equal to 2.8. It's like this. If f of x is equal to f of y, then I need to show that your x is equal to y. But you have it as x is not equal to y in this case. And therefore what can I say here? Your f is not 1 to 1. Got it? Now here coming over to the next one, consider 0.5, okay, as just a value. It is known that it doesn't have a pre-image in this case. It is always an integer. Therefore you say that it is not onto, or in other words your range is said to be a subset of the codomain. For example, you just take the arrow diagram in this case. The set of all real numbers, I have it as 1.1, 1.2, 1.3, etc. Similarly here also 1.1, 1.2, 1.3. Now here if I say f of 1 is also 1, f of 1.1 that is also 1, f of 1.2 that is also 1, f of 1.3 that is also 1. But here if you see in this case, if I take 1.1, will it have a pre-image? No. That's what I mean by saying here your 0.5 here if you see it will not have a pre-image. Only the whole numbers will have pre-images here, and all the other numbers will not have pre-images, and therefore we say that it is not onto. In other words, your range is said to be a subset of the codomain, and therefore your function f is not onto. So it is not 1 to 1 as well as it is not onto. Correct? Now here your fourth question, show that the modulus function f from r to r given by f of x is equal to modulus x is neither 1 to 1 nor onto, where modulus of x is x if x is non-negative and modulus of x is minus x if x is said to be negative. Got it? So here you know what is modulus of function here. So when I take f from r to r, so I've just drawn the arrow diagram here. So for 0 it's going to be 0. So what is your f of mod 1? Your f of mod 1 is nothing but equal to 1. Okay, mod 1 is equal to 1. Similarly, what is f of minus 1? F of minus 1 will give me what? Minus mod 1. What is minus mod 1? That is also nothing but equal to plus 1 itself actually, because minus of minus will give you what? Plus 1. So here when you take, in this case, all the positive numbers on the codomain only will have a pre-image. And in other words, if you see here, in this case, it doesn't have unique images also. So here in this case, it's not 1 to 1 as well as it's not onto. So here we see how we have done here. If your f of 1 is equal to mod 1, that is equal to 1. F of minus 1 is equal to mod of minus 1, that is also equal to 1. So if f of 1 is equal to f of minus 1, what will you get here? 1 is not equal to minus 1, and therefore f is not 1 to 1. This is what you get here. So all the elements in the codomain does not have a pre-image. That is, your range is also a subset of the codomain, and therefore f is said to be not onto. Okay. So yeah, okay, this is over. Now the fifth question, show that the signum function defined by f from r to r is given by f of x is equal to 1 if x greater than 0, it's equal to 0 if x is equal to 0, it's equal to minus 1 if x is less than 0. It is neither now on 1 to 1 nor on 2. Okay, so here it's neither 1 to 1 nor on 2. This is what you'll have to prove here. So I've just drawn the arrow diagram in this case. So it is a set of all real numbers to real numbers here. So there is one thing, when x is greater than 0. So when I take f of 1, that is also equal to 1. When I take f of, what is it here, 1 by 4, that is also equal to 1. So when I take f of 3 by 4, that is also equal to 1. When I take f of 2, that is also equal to 1. This itself shows that it is not 1 to 1 actually here. Okay. Similarly, when I take f of minus 1, what is it equal to here? That is equal to minus 1. Similarly, when I take f of minus 2, that is also equal to minus 1. Why I write it to be equal to minus 1? So if x less than 0, your f of x is equal to minus 1. That is what I have done in the arrow diagram. So if x is equal to 0, that has got a unique image, but not others. 1 to 1, 2 is also to 1, 3 is also to 1, like that actually. So it's not 1 to 1, plus all the elements other than 1, 0 and minus 1 does not have a pre-image. In other words, your range is only a subset of the codomain, and therefore you say that f is not 1 to 1 and on 2. Okay. The sixth question, let a be equal to 1, 2, 3, b to be equal to 4, 5, 6, 7, and let f be equal to 1, 4, 2, 5 and 3, 6 be a function from a to b. Show that f is said to be 1 to 1. So given a be equal to 1, 2, 3, b be equal to 4, 5, 6, 7, f from a to b is said to be defined as f is equal to 1, 4, 2, 5 and 3, 6. So it means that 1 is mapped on to 4, 2 is mapped on to 5 and 3 is mapped on to 6. Of course, in the codomain you have 4, 5, 6 and 7 that I have written, but this doesn't have a pre-image. Okay, so that's not a problem for to show that it's 1 to 1. I need to show that it is only 1 to 1. So when you look at this arrow diagram itself, you know all the elements in the domain, they have unique images, and therefore I can say that f is said to be 1 to 1. Got it? Now here your seventh question, in each of the following cases state whether the function is said to be 1 to 1, on to or bijective. Justify your answer. So here f from r to r is defined by f of x is equal to 3 minus 4x. It's a polynomial here. So first whether we'll show it is said to be 1 to 1 or not. So f from r to r is said to be given by f of x is equal to 3 minus 4x. So if f of x is equal to f of y, you get 3 minus 4x is equal to 3 minus 4y. Your 3 and 3 gets cancelled. So you will get x to be equal to y, and therefore you say that your f is said to be 1 to 1. Got it? Now to show that it is on to, earlier it was easy for me to draw the arrow diagram here. Here also I can draw the arrow diagram, but in here we'll just see by like this. Here this f of x, I will take it to be y to be equal to 3 minus 4x. So you get 4x to be equal to 3 minus y. So you have x is equal to 3 minus y by 4. So what is your f of 3 minus y by 4? This is equal to 3 minus 4 into, substitute it. You know what is your f of x. What is your f of x equal to? 3 minus 4x you get here. So when I substitute in the place of x by 3 minus y by 4, you will get it as f3 minus 4 into 3 minus y by 4. 4 and 4 gets cancelled. So you'll be left with 3 minus of minus is nothing but plus y. So you will get it to be equal to y. So the inverse image also it must be equal to y. Then I will say that your f is said to be on to. In other words, we say that it is said to be bijective. Okay. Now here the eighth one, let a and b be sets. Show that f from a cross b to b cross a such that f of a comma b is equal to b comma a is a bijective function. So what is given here? F from a cross b to b cross a, that is given by f of a comma b equal to b comma a. So you'll have to show that it is 1 to 1. So how do I show that it's 1 to 1? If f of a1 comma b1 is equal to f of a2 comma b2, you know what is your f of a1 comma b1. What is that equal to? b1 comma a1, that is equal to b2 comma a2. So I will say that if the ordered pairs are equal, the corresponding elements are also equal, and therefore I can say that it is said to be 1 to 1. Got it? Now here we'll have to show that it is said to be on to. So how do I show that it is said to be on to in this case actually here? for b comma a belonging to b cross a of any element, then there exists, that is for all the element in this set here b cross a, you will have a pre-image. Okay, so that's what they mean by saying for every b comma a belonging to b cross a, there exists an element a cross b such that your f of a comma b is equal to b comma a. Therefore you can say that it is said to be onto, and thus you say that it is said to be bijective. Got it? Yes. Now here your ninth question. Let f from n to n be defined by f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even. For all n belonging to n, state whether the function f is onto, 1-to-1 or bijective and justify your answer. So it's given in two parts actually. One is odd and the other one is said to be even. So here first we'll check whether it is said to be 1-to-1. So what is the question given here? F of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is said to be even. So we'll take f of 1. What is your f of 1 equal to? 1 plus 1 divided by 2 you get. That's nothing but equal to 1. So here when n is even, I will have to take an even number. So 2 by 2, that's equal to 1. So what is that actually here? The same element, two different elements have got the same image. That itself shows that it is not 1-to-1. So if f of 1 is equal to f of 2, then you say that 1 is not equal to 2, and therefore you say that it is not 1-to-1. Got it? Now here your case 1, when n is said to be odd. So what do you mean by saying when n is odd? Let n be equal to 2r plus 1 you get here. So n is equal to 2r plus 1. So here there exists a 4r plus 1. Why do I write it as 4r plus 1? Because it is n plus 1 divided by 2. So when it goes to the other side, it will be nothing but twice of that. So we have it as 4r plus 1 such that your f of 4r plus 1 is equal to 4r plus 1 divided by 2. So here it gets cancelled and you are left with only 2r plus 1, and therefore you can say that it is said to be onto. How do you get this 4r plus 1 actually here? You will write it like this actually here. Okay, so in this case suppose you have it as 2r plus 1 is equal to n plus 2 etc. here. Okay, so 2r plus 1 is equal to n plus 1 divided by 2 you get here. So here when you cross multiply etc., what will happen? 4r plus 2 is equal to n plus 1 you get. So n is equal to, taking it to the other side, you will get it as 4r plus 1. That is how you get it as 4r plus 1 here. Okay, I am not writing anything on my own here. Okay, just like I told you earlier, no? So it is equal to 2r plus 1. So it is said to be onto when n is said to be odd. Now when n is said to be even, generally how do you take it actually? Here even numbers are nothing but just multiples of 2. N is equal to 2r. So if I want to show that n is equal to 2r, then as the same way you know that n by 2 is equal to 2r you get here. When I cross multiply, you will get n is equal to, what will I get here? 4r. So 4r belongs to n such that your f of 4r is equal to 4r by 2. That's nothing but equal to 2r, and therefore I can say that my f is said to be onto. So if f is 1-to-1 as well as onto, and therefore I can say that it is said to be a bijective function. Okay. The 10th one, let a be equal to r minus 3 and b be equal to r minus 1. Consider the function f from a to be defined by f of x is equal to x minus 2 by x minus 3. Is f 1-to-1 and onto, and justify your answer. Okay, so here it is given as a to be equal to r minus 3 and b be equal to r minus 1. So here you have let x comma y belong to a. So you will have f of x is equal to f of y. First we'll check whether it is said to be 1-to-1 or not. Okay, so how do I check actually here? If f of x is equal to f of y, then I must have x to be equal to y. So you know what is your x? It is x minus 2 by x minus 3 equal to y minus 2 by y minus 3. Cross multiply it. You will have it as x minus 2 into y minus 3 is equal to y minus 2 into x minus 3. Multiply it. What will I get? xy minus 3x minus 2y plus 6 you get, which is equal to xy minus 3y minus 2x plus 6. Okay, so here if you see plus 6 and plus 6 gets cancelled, xy and xy gets cancelled. So when I take it to the other side, you will have it as minus 3x plus 2x is nothing but minus x. Here again when I take it to this side, you get it as minus y. So you will have x to be equal to y here. So it is said to be 1-to-1. So f is said to be 1-to-1 in this case. Got it? Now to show that it is said to be onto, what will I do? Let y be equal to x minus 2 by x minus 3. So we will write x in terms of y, substitute it again, and you must get it to be equal to y here. So when I cross multiply, it is xy minus 3y is equal to x minus 2. So what will happen here actually here, I'll just take this to the other side. Xy minus x is equal to 3y minus 2 you get. So x into y minus 1 is equal to 3y minus 2. So what is that you will have here actually here? Your x is equal to 3y minus 2 by y minus 1 belonging to A, where your y is not equal to 1. So we'll just substitute it here. What is your f of x you know? What is your f of x equal to? X minus 2 divided by x minus 3. So what is the value of x here? X is equal to 3y minus 2 by y minus 1 minus 2 divided by 3y minus 2 by y minus 1 minus 3 you get. So when I cross multiply, what will I get? 3y minus 2 minus 2y plus 2 divided by y minus 1 divided by 3y minus 2 minus 3y plus 3 divided by y minus 1. This gets cancelled here. 3y minus 2y is what? Y. Minus 2 plus 2 gets cancelled here. Here also it gets cancelled. Minus 2 plus 3 is nothing but equal to 1. You get it as y, and therefore I can say that it is said to be 1 to 1 as well as on 2. Okay.